Hello and welcome. The lesson discusses about the various components and peripherals available on the Atmega 328 microcontroller. It provides 32 kilobytes of on-chip in-system programmable flash memory. It is also called program memory as it stores the program flashed to the microcontroller. The memory has the endurance of at least 10,000 write or erase cycles. The flash memory is organized as 16K addresses of 16-bit length as the AVR instructions are either 16-bit or 32-bit long. A 14-bit program counter is used to address the flash memory. The flash memory is divided into two sections, bootloader and application program sections. The microcontroller also contains 1 kilobyte of EEPROM memory, that is electrically erasable, programmable, read-only memory, and is a type of non-volatile memory used in computers integrated in microcontrollers and other electronic devices to store relatively small amounts of data. It is organized as a separate data space in which single bytes can be read and written. The EEPROM has an endurance of at least 100,000 write or erase cycles. The microcontroller provides 2 kilobytes of SRAM. SRAM stands for Static Random Access Memory. It is a volatile memory, meaning the data stored in SRAM is lost when power is removed. It is also called data memory as it stores the data during program execution. Notice that the flash and SRAM are connected to the AVR CPU through different buses. This is the differentiating characteristics of Howard architecture. The separate program and data buses enables the microcontroller to access the program and data memory independently and facilitates CPU pipelining. The CPU prefaces the next instruction while the current instruction is being executed. The clock generation module supports various clock sources and can be configured by setting appropriate value in the clock select bit in fuse bytes. The microcontroller supports low power crystal oscillator, full swing crystal oscillator, low frequency crystal oscillator, and has two internal RC oscillators, and it can work with external clock too. The device is shipped with internal RC oscillator enabled and clock divide by 8 fuse programmed. The frequency of internal oscillator is 8 MHz and clock divide by 8 results in microcontroller running at 1 MHz. There are 3 timer counter units with compare mode and PWM and a real-time clock on the microcontroller. The timer 0 and timer 2 denoted by TC0 and TC2 respectively are 8-bit timers and TC1 is a 16-bit timer. It also provides a programmable watchdog timer with internal oscillator. Watchdog timer is used to recover the system from software failure by resetting the system. TC2 supports asynchronous mode. It is operational in power save mode and allows user to maintain a timer base while the rest of the device is sleeping. The microcontroller supports 3 serial communication protocols, namely SPI, TWI, and the UART. The Serial Peripheral Interface (SPI) allows high-speed synchronous data transfer between the device and peripheral units, or between several AVR devices. The in-circuit programmer used to flash bootloader and application uses SPI protocol. The Universal Synchronous Asynchronous Serial Receiver Transmitter (USART) is highly flexible serial communication device. The USART can also be used in master SPI mode. It is commonly used to communicate with the development PC. The two-wire serial interface protocol, that is TWI, allows the system designer to connect up to 128 different devices. The TWI is compatible with Philips I2C protocol. The microcontroller has 3 GPIO ports which include 23 I/O lines. The port B and D are 8-bit wide, whereas the port C is 7-bit wide. The general purpose input-output is used to communicate with peripherals. The individual GPIO pins can be configured independently and have symmetric drive capabilities. That means the pins can source and sink same amount of current when configured as input or output. The microcontroller supports 2 external interrupts and 23 pin change interrupts. It also supports the interrupts from watchdog timer and other timers, SPI, USART, EEPROM, analog to digital converter, and analog comparator. The microcontroller also provides analog comparator and analog to digital converter. The analog comparator compares the two voltages and sets the analog comparator output accordingly. The comparator's output can be set to trigger the input capture function of TC1. The ADC converts an analog input voltage to a 10-bit digital value through successive approximation. The microcontroller supports 6 sleep modes. Sleep modes are used to save power by enabling the application to shut down unused modules in the microcontroller. The various sleep modes allow the user to tailor the power consumption according to the application's requirement. The power management of ATmega 328 supports brownout detection. The BOD circuit monitors the supply voltage and resets the microcontroller if the supply voltage falls below a predefined threshold. The trigger level of the BOD is selected by baud level bits in extended fuse byte. The table shows the maximum power rating of ATmega 328 microcontroller. The voltage on any pin except reset pin must be in the range of minus 0.5 volt to VCC plus 0.5 volt with respect to the ground. The reset pin allows the application of minus 0.5 volt to 13 volts. Higher voltage is applied to reset pin in high voltage programming mode to rescue fuses. The maximum operating voltage of the microcontroller is 6 volts. The I/O pins can source and sink 40 milliamps of current, and the VCC and ground pins should not be supplied current in excess of 200 milliamps. Take due care not to exceed the voltage and current ratings. The application of excessive power damages the microcontroller and the development board. With this, we come to the end of this lesson. Have a great time. Thank you.